Okay, I think it's time to begin. So welcome to the second afternoon session, which is titled Ethics and Human Factors. We have three presentations. The last one was pre-recorded by Mikko Virtanen from Workspace. But we will begin with Martti Lehto's presentation about cybersecurity architecture in the e-pilotage system of systems.
Thank you. Welcome this afternoon presentation. So I am professor of practice in the University of Jyväskylä in cybersecurity, and my colleague Jouni Pöyhönen is here also, who knows all the technical details and mathematical perspectives about this architecture. So I make the presentation and he will answer the difficult questions. So the starting point in our research program is that cybersecurity is driven by knowledge of vulnerabilities, threats, assets, potential attack impacts, and the motives and targets of potential adversaries. So like we discuss here, what happens, for example, in Ukraine and those things, we are focused those things. What is our assets? What are the vulnerabilities and threat against those? And what are the motives, the targets of the potential adversaries? So, and at the main area, the idea is the system of system view. So not only looking this e-piloted systems as a part or a device or one element. So more focus the whole systemic view, because our possible opponent try to find in that whole system the weakest point, the weakest link. So the main question of our research was that how can the cybersecurity risks of information flows in automated remote piloting faraway operation be evaluated? So the focus was more like the process itself, how to do that cybersecurity process in that system of system environment, and what could be the framework and infrastructure of cybersecurity in remote piloting systems. This has been very nice trip to us, because Jouni and me background is Air Force over 30 years. So now we are focusing maritime environment and looking at that from Air Force perspective. But there are many same elements from systemic perspective. So first of all, we start is that what is this communication network? What are the information flows? Okay, we have some challenges in the very beginning to find and describe. And this is from Bright House, I think, picture. What is this information flows like? And what are the main important information? Like movement of the ship, speed, the rate of turn, for example, dimensions and locations of the navigable fairway, positions of the ship, maritime age to navigation, and other vessels, environmental conditions, safety related communications, and so on. So there are a lot of different communication, and the first thing we made is describe this communication network and the information flow. And then we describe using this kind of block diagram what is the system. Like we put the ship system in the middle, and then we have this fairway, we have controlling elements plus security control center as a SOC, and we have these weather operator stakeholders, BDS and other vessels. So try to looking the relations between different blocks in that remote piloted systems. We have our previous research make this kind of framework for our study. For example, the cyber system layers we have using this 5th layer framework, where we have this physical layer, where we have all these physical communication and information networks and different devices. Syntactic layer are the system control and management programs, how to put the systems together. Semantic layer is the information and data sets. What is the information? And services, because there are different types of services using these remote piloted systems and the hardware elements and so on. And the cognitive layer is like the users, what we are thinking. And we can looking at that like strategic, operational, and technical, tactical level. And this is what we create. So we have the cyber threat analysis process, and we have the cyber risk management process. And the starting point is that, like the analysis of the organization, the system, what is in the focus. So first of all, as I described, we made the system of system description. What are the technology used in this remote system? Processes and data flow. After that, we look into threats. We're using this, we use that the same motivation framework, other research is that question of vandalism, cybercrime, espionage, terrorism, sabotage, or warfare threats. What are the vulnerabilities in the cyber area? We many times use these people, processes, and technology. What are the attack vectors against this piloted system? What are the indicators of intelligence? And then about the impact. If something happens, what are the impacts? And then we have this risk management process, which are quite traditional way, risk identification, analysis, significance of the risk handling, and then we have these measures. This is like example that about these different levels from, for example, in strategic level process, e-piloted system is system of systems. Operational levels, we have the communication systems, and tactical level, we have, for example, VHF. What is one example? And then after the process, when we create the measures, we have like strategic level policy, operational level target architecture, and system level the technology and like the device-based measures. So, and then we use these attack tree elements and some mathematical formulas about the probability defense against the attack. So question is, can we use this mathematical approach to solve the problems, what we should do as a defender against the attack? This is not very easy to do, so we make some training and testing about this, but it gives information about the methods as a defender we must do against the attack using that probability tree methods. Then we create this kind of table as a tool, recognize the risks using relevant references and like estimate this risk evaluation. This is only the like the table. We don't use that at all. We only create that as an example. And then when we put together these different layers and strategic perspective, operational and tactical perspective, we can create this kind of visual information. This is not real data at all. It's only like describing what we are doing. And then this risk level mitigation action priority. We have the information flows, different type of those. Then we have risk level. This risk level analysis we use like expert Delphi methods. We discussed with Brighthouse, I think.
Yes.
Brighthouse asking about the risks, high, medium, low. So it's more like expert analysis, what are the levels. And then we have these defense categories, what we can do, and risk level mitigation. And then we have this action priority, 1 to 3. So 1 meaning that it's most important, and 3 is okay. For example, like if the risk level is low, it is in our priority 3rd. So this method shows what are the risks with our different categories, risk level mitigation methods, and priorities. Because many cases we should prioritize what we can do first and then. We cannot do everything together.
Martti, may I ask a question? Is there a price cost in a way that risk is low and action something, but is there like a cost of that action, or is it part of the kind of a analysis? Does it matter?
I think, yeah, no. That maybe I don't understand what you mean. So, but
How much does it cost to do it? What is the price tag?
can you say?
Yeah, we haven't come so far at the
Yeah.
moment, but it can be calculated and it depends on the organization, of course, or what is who is going to do these mitigation activities. But it can be done later on. But at that phase, the focus was to discover what are the risks, how they can be mitigated, and what is the priority of the risks.
Yeah, thank you.
Yeah. But that is part, pricing is part of risk evaluation DIMECC.
What we produce is 6 conference papers and 1 doctoral thesis. So we have when we start, we make these questions where, why, and what. So we present those in USA and UK conferences, we start with basic elements, for example, and then threat analysis and threat impacts, analysis in the ships, and the last one are like the assessment of cybersecurity risks. So we, using our methods, what is the situation, what is the elements, what is the system, then the threats, vulnerabilities, and then this assessment of cybersecurity risks. And Tiina made like this doctoral thesis focus on the complex system environment and use this as a case study. So the conclusion is that the main cybersecurity risk assessment elements are this threat intelligence and risk management. So we must first look at the threats, vulnerabilities, describe the environment, and then use this risk management process to find the most important areas to mitigate the risks. So we continue in this Smarter program to make this process and architecture better one, and we're working also our colleagues in US in the Texas A&M University to write maritime cybersecurity white paper. It should be ready next year. So we put all those together, create like this kind of white paper about this thing. Thank you.
Thank you, Martti. Do we have any questions from the audience?
Did you recognize what was the biggest threat? Like most high risks in that system of systems in this context? Were there any clear?
We didn't make any like real data analysis. We made more about like the framework, what it could be. So
will you be then applying the framework in this context of smarter?
So if I'm thinking in that case, what is the main risk? The main risks are, of course, we make the prioritize our systems. What is the most important system in this e-piloted systems? And this is like GPS, because we use the satellite communication. And as many said about the spoofing and jamming, what happens if somebody is spoofing or the system is jamming? And as others described, they are hopefully different other systems helping if one system is like under the attack. But if I am the attacker, I try to find what is the most important element. Maybe communication between the remote pilot and the ship. Because it's crucial that the captain in the boat or ship get the information. And other thing is that situational awareness and situational picture is that totally correct. We have some examples spoofing in air traffic communication, GPS, meaning that the pilot and the air traffic controller don't know exactly where the planes are. And that is the most crucial thing in air. And I think in the maritime there is the same situation. If the boat side, they are not sure is the position of the ship accurate enough.
Okay, thank you very much. And Ville, since you are already talking, I'd like to welcome you to stage. So Ville Vakkuri from Jyväskylä University will talk about ECOL method.
Yeah, what does it matter in maritime context? So let's see how this works. Yes, I will be talking about ethical method from software engineering domain called ECOL that we have developed under this program, and what does it matter in the maritime context? In the context we are relating inside this consortium. So first I would like to start who we are and what have we done, because I will be only focusing on one result from our side. But we have Pekka Abrahamsson here. Pekka was happily shaking everyone's hand and active at the coffee, so maybe you have met Pekka. Erika Halme, she couldn't be here today, even though she tried, but she has been working with ethical requirements, and she's our lead researcher in the sister program of Smarter, the terminal side of this program. Marianna Jantunen is working with Erika on the ethical requirements, and she actually did her master's inside this program. That's already one of our results. And she was the one looking into the actual guidelines that are I would say guiding the ethics discussion in both academia and industry. And she also did the mapping at the start of this project where actually these kind of piloted systems are done. In what countries, in what academic context we are investing in digital solution for the maritime sector. Mami is here today. Mami is working with AI governance, one of the rising areas on AI discussion, and I'm here. I have been, I would say, the conjunction point of our work, working on how to implement ethical consideration and guidelines to actual software development and to the context of maritime. So I would like to start with the actual context. And I thought this might be a bit more challenging, but after listening to the discussions from the previous session and on the, morning session, it might not be so challenging after all. So why do we need to consider ethical implications of software solution in future fairway or remote pilotage? So we will be doing more and more sensoring. Bright House have had a really bright light today on whatever they have been doing inside this program. We will be having a higher reliance on communication, just like Martti said. There will be new digital system and new players to the field, not just traditional maritime operators or maritime I would say industry members. There will be software companies involving more and more with the ship systems and also with the harbor systems. There will be new processes. We have been asking what is the remote pilotage process? Do we need to replicate or simulate the one that we are already doing, having the pilot on board, or can we change the process? And if we are changing the process, we are adding new digital components to that. New stakeholders, and there will be implementation of AI solutions. And when we implement AI solutions and higher capabilities to this system, we need to have more awareness of the possible ethical outcomes of those and challenges. And also, as Martti mentioned, and already it was mentioned many times on Sanna's presentation from Finnbuild, we are creating complex system of systems that we might not know how they work together, but we still need to manage that one. And the ethical aspect of that can be one that is complementing the technological viewpoint. So there's a good tradition, I would say, an outstanding tradition in pilotage about having the human lives on forehand and really mattering on addressing safety. But are we willing to address safety and also this kind of like value-based approach also for the IT solutions that we are providing for the maritime context? And that's where we are relating to also. So I would say that in that way, maritime has a really good tradition of valuing something that is not just monetary based, but really something that is hard to measure, for example, human lives. Okay, if you're not yet convinced why we should focus on ethics, we can look at the governmental strategy and regulation on EU level and in Finnish level. What is happening with the, for example, upcoming EU data acts and so on. Policies are driving the field and also standards. On the morning we have been discussing more about almost say communication standards and actual technical standards, but alongside those also in ICO and IEEE software standards, how and software process standards are coming. How the software components should be developed that they are applicable for the field, how they are safe and secure, or they uphold the right values. Taking a different aspect, international organizations that actually provide the professional code of conduct for software engineers. They have been also requesting and demanding more ethical aware, I would say, software engineering. And of course, there is the social acceptance. What, for example, if the remote pilotage wouldn't be accepted? Can the ethical consideration and transparency on those help the industry, actual pilots, the workers' unions, and the whole society accept these services? And ethics can really help with that, clear out the values and I would say hidden value structures that there might be there. And the ethical demand is coming. We have the IEEE standard, I would say background work for the standard. We have the, I would say, EU guidelines. The code of conduct for software engineering has been evolving. Companies are asking it, governments are asking it. So the demand is high for ethically aligned or ethically aware software development, especially with highly capable systems as machine learning systems. Then the other way to ask the question, how should we then address, if we recognize that the ethical issues they matter and we should implement them? Should we address them with principles, what we value, what we see the most important? Should we implement through guidelines saying that this is how things should be done? Should we have ethics boards asking like, is the product okay, like in medical trials we have? Or should we have technical solution mitigating one single, or maybe, for example, like attack vector? So we are mitigating only one, and Martti had a small red box in his presentation, only one thing, even though we should be addressing the whole big picture. So all of these are in the ball, I would say, on the table, and we are saying that this is not enough. we need to have practical solution for practical people. So software engineers are not so well versed on ethical and philosophical debate. So by drawing them guidelines or values that yes, implement safety is important, implement safety, or environmental friendliness is important, implement that. But what does it actually mean for the engineer? What kind of outcomes there need to be, for example, in the program to be addressing those issues? So our main focus and main research question, how to implement ethics in software development. And just to clarify, because AI ethics is a really huge area of research with long history, we have not been focusing on intelligent systems and how they can be morally aware, or for example, if we would have an autonomous ship, what kind of moral code it should be running. No, that's totally out of scope. We have been focusing on the actual software engineers on the design level and development level. So what kind of methods they will need to have to help them to do their actual work and implement these new things. And also then on more higher level on the standards, codes of conduct, certification. So what kind of safeguard or framing we will need to have around inside the industry that ethics would be implemented. And in our work, we recognize that if there would be this kind of method that would be implementing this really practical, tangible software engineer level solution, software, I would say team level solution, the method should be practical and simple. I will come back to that. What does mean practical and simple? It needs to be modular and agile, because often in software development you have more ideas than you have resources or time to do. So you need to be able to take some elements and then change depending on what the project is highlighting on. And most of all, the method should have a capacity to empower users. So those who are not familiar with the topic can take part in the discussion. For example, companies buying software solutions, or the software engineers developing solutions, or even the regulating level for governmental offices looking into these solutions. So summarize this all, we developed Eccola. Eccola is an empirically validated tool to address, I would say, the most relevant topics of AI ethics discussion, but still that transfer to overall software engineering. And in this framework, we have 8 themes analyzed, that is more about on the meta level discussion, like understanding the context. Then we have about transparency, safety and security, fairness, data, agency and oversight, well-being and accountability. And those are all color-coded and also thematically named. And the Eccola method is presented as a card deck. So each of these will create their one card with one issues related to that and one questions to help drive the discussion around that topic. The Eccola was developed with empirical software engineering mindset. So we developed something, we tested with actual audience. In this program, Awake has been an active partner, giving us feedback from the software engineering point of view, what needs to be changed from the method, and also with our many other companies also there. And the result has been published in, I would say, top-level venues, and also is available on, I would say, open access approach. But the work has been going on, and today we will also take some small detour. How has this Eccola work affected this program? In Eccola, each of the cards is structured in a similar way. So there is the card theme that is given with the color coding and also then and textual. Then there is a number for the card and card title. There is a short motivation that the people, the reader who have never seen this card could understand why it is important. Then there are these questions. They're not just action points that do this and you're okay, but it's more about let's approach this theme through these questions. And we try to be really open-ended, that we want to drive the critical thinking and give tools for open discussion about the program. And if you don't really still catch up what is the idea of this card, we have also given a really practical example here, like what could it mean in one similar case. And I think this is a good opportunity also to look back to the what does it mean that we aim for practicality and usability in this way? We used to have an academic citation here. Like if you want to read more about this topic, read here. We had a academic viewpoint to that. Like, okay, of course, if you're interested, you will go and look more. But what the actual software engineers did, they never went to see the resources. They wanted to have the card there and then work with that. So we changed it to address their needs. And also one other thing that when you're programming, when you create a documentation, you want to reference something quite fast and quick. So that's also why we have numbering on each of the cards and also on each of the topics. For example, if you would be working with card 3 and for example then in question 5. It would have been nice to have Bright House here because I would have wanted them to play with this card and see, for example, could have we named something. For example, what is the goal of the system or why this is deployed in this area? So what would have they said for the remote pilots? But as you have some background with Awake and looking, for example, just-in-time arrival, with this card, could you say that what was the goal for just-in-time arrival inside this program that Awake was doing?
Awake was focusing on the ship side compared to what Turku University of Applied Sciences and Åbo Academy are focusing on the truck traffic, but the goal was to share voyage information in a way that ships do not rush into the ports, what they sometimes do, but they would share the information of their speed, destination, possible cargo, and that way optimize the speed and save bunker fuel.
And in this way, for example, we could have started documenting what the actual goal for Awake was for the system and how things relate to that. And could you have answered the second question also that, well, were you discussing these kind of points?
You mean within Awake?
Yeah.
Sure, but the difficult part in that context is the whole maritime transport system. A single company cannot really affect it. We need to change, well, not regulations, but the way companies are actually handling their customers, meaning ports or different port stakeholders, because they are serving on the principle first come, first serve, and that is something that should be changed soon.
Yeah, I think this is also
I can comment. We have changed that with the virtual arrival system. That might be interesting for you.
Yeah, but I think this is also a good example how these cards work. That because they are not just used by software developers, that they are using the ones managing the teams and also with the customer collaboration. So in that way, maybe ESL Sitpin have had something to say about that, and maybe Awake has changed something. Like also you have had a venue for this kind of collaboration and discussion on that topic. So they are, in the most, I would say, elemental level, they are opening discussion around the topic, and then it provides a venue to document that. Okay, and to have bit more context, even though we had really nice examples there, we use these cards also in this program. One of the tasks that we were addressing in VP4 was the future roadmap. What will be coming in upcoming years in the forest? What is happening in Foresight? And we run these future Fairway workshops. Virpi was there active, and many of you were there giving comments also. And we use the Ekkola cards there to give us some kind of tangible ways to address what might be there in the future. So in each of the discussion rooms or World Cafe tables, we were having this discussion through the cards and through the themes that were given there. And then by categorizing these, we were able to see, for example, what would be important in the future. So Ekkola was already serving basically outside the original context in that way, giving us some kind of direction and way to address these problems. And this is one from accessibility that is also one of the cards in Ekkola deck. And I really like this one because this was, at least on the panel discussion, this was the language barriers when where there is lack of bodily language, the body language. So addressing issues even totally outside the software engineering context. Eccola can serve as a tool to recognize and address the I would say the domain area that we have here, and we had really good examples on the panel discuss about the importance of the like non-verbal communication. What does the captain see, and what does the captain feel from the pilot, and also what does the pilot feel and see from the captain. So this was the one application area that we used Eccola inside this program. And this is the other side of the thing, how Eccola, we plan to Eccola to run in software development. So it would be working so that during the process, you would select some of the cards that the software engineering team is addressing. Then you would view and take some actions based on those cards. You would document it, and in that way create transparency on the actual discussion, like what is valued and why. Often these discussions are held in software companies and or software teams, but they tend to happen during the coffee breaks or in this informal discussion, so it's never documented in the actual project level. So in that way, it could create transparency to the process. And also those things that are out of the scope, because not everything can be solved inside one program or one task. So clearly stating out what things are not done and why. And this cycle would be running as long as the software development process would be going on. You will be taking different cards when you will be addressing different questions. For example, there is one for cybersecurity and that side of the world. So what is the actual contribution from the Eccola work that we have been doing, and what are the, I would say, recognized gains from this? So for software developers and designers, this gives a simplified way to address ethics through concepts and really with some kind of verbal basis. So you can start a discussion with this. In that way, you can also document that what you are doing and also communicate with your customer. For product owners, the middleman often between the software development team and the actual client company, that could be, in that way, he would have more tools to address. For example, if the customer would be asking, we want to address ethical issues in this product, okay, then the product owner might be looking, okay, what kind of competencies I have to reply that, but Eccola might give tools for addressing that. Asking, because ethics is so wide question, okay, what do you mean by ethics, ethical awareness, for example? Do you mean environmental things, human well-being, cybersecurity, or privacy? I have emphasized for the viewpoint of buying companies or software acquisition, because point is we can change the field already. For example, especially big governmental buyers for software, not just by legislation, but also by demanding different aspects from software companies, that they can change the overall view on the field. Often with, for example, AI products, they are being developed so fast and so with new context that the legislation is always behind. But for example, creating this kind of awareness for the companies and governmental bodies buying this system, you could create in that way higher standard for ethical demand. And of course, consultants working as a mediators between these. This was my fast presentation on Eccola and what we have been doing here.
Thank you, Ville. Any questions? Yes, please.
Are those cards like the living document or living cards, or are they like fixed and that's the perfect?
Yeah, we have agile core here, meaning that we need to change those cards. And actually, Mamia in her work have suggested that no, Ville, you have missed it totally. You need to have a governance card there. So we are open for applying. We have some information in the cards, but also because the AI ethics field is changing and we are learning new things, it's not, I would say, it's not full and never will be a full. Because we have also recognized that companies, when they see the cards, say, okay, but we want to create this and this and this because these things are important for us. But it gives them a medium to communicate that. So some kind of structured way to say that, okay, for example, in Mamia's case, if I want to talk about governance, I can formulate like this, and it might be a bit more understandable in that way. Yes.
Are these cards for free, or is there some licensing?
No, we have done everything that we have done. Also inside this program, we have done as open access. So everything is available, and also these cards actually, hopefully this week, at latest next week, we will have the card set also in GitHub. So those of you who are interested in programming with these, they will be available on online repository. But they are already available as a physical products and also on Figshare as a printable material. But we have learned also during these Corona times that even though software teams often work with physical product like post-it notes and paper sheets, that in Corona times maybe we have learned to be a bit more, I would say, digital in that manner. That we have really good examples also using these cards purely on digital platforms. So both of those are available, and we are happy to talk more about that.
Is there any? I mean, ECOLA has been out for a good part of the year. I mean, over a year already. Has there been any critique against ECOLA by other researchers or?
Yeah, they have been critiqued, especially like, why did we only include 8 teams? Because ethics is vast, and as I would precise, like more you scope down, more things you notice. So why do we have only these 8 teams? Because they could be easily 40 teams. But I think those criticists, they have replied that question by themselves, because they try to implement all the 40 teams, and they realize that there is huge information overload. It's hard to manage that kind of new intake of new information. So in that way, it's a balancing act with the sizing, but it should be agile in that way that if you notice something is missing, you could add it there, and you should add it there.
How did you end up in the format of playing cards? Because a typical approach would be a huge Excel sheet.
This comes back to the practical point of view. So in our team, we have experiences from software engineering and also monitoring software engineering teams. So how do they work? And often, for example, when defining requirements, it's easier to just fast and write something, especially when you're working as a team, to have a physical object there. And also, for example, planning poker and other these things, they are traditional physical objects in software engineering. So so we continued that medium, and that was the reason for that. But we have seen also companies transferring when they have first sorted out the cards and make an observation, then they have started building their own Excel about that.
I like your approach.
Okay, thank you, Ville. Next we have Virpi from Aalto Arts. Welcome.
Yes, thank you. Yes, so how many of you saw Arne's presentation in the other room before the break? Yes, some, not many, but we are working in the same team in Aalto Arts with Arne, and I'm talking about a bit broader topic of work transformation, but based on the same data. We have interviewed pilots and also some questionnaires for them about user experience and meaningfulness of the work. So, based on those aspects, I will move on once I figure out how.
Other direction.
Wrong way.
No, that's good topic.
And that's also. I could talk about it. I don't know if you would like it. So luckily I have also Johanna from Novia joining me for the last 2 slides there, because you have been working on work transformation topics as well. I cannot understand. Yes, I pressed the same button. So, how to design for work transformation? Obviously, you should start by understanding the current ways of working. And the reality is really rich. So we try to understand as in-depth manner both the pragmatic and psychological aspects of work. Because often when we talk about automation, we put in a system and then we think that, well, the human is one part of the system treat the human like a robot who has certain tasks, uses standard language when working, and so on. But there's also psychological needs for people to enjoy their work and find some meaningfulness in their work. So we try to understand both ways, pragmatic and psychological aspects of work. And then, of course, the future opportunities are there, and that's why we are trying to understand this work transformation. How does the future change, and how does it change the work of people? And we have studied pilots only, although there are many stakeholders in this area. But, those who will move from the ship to the remote office. So we have studied the stakeholder assumptions a bit, and Arne has done a lot of work on that, if you want to know more. So there are many open questions still, and that's why this work has been very challenging, because we don't really know much what is the future work gonna be about. We have used a method called service experience design that we have been developing. Service design is very well fitted to this kind of work transformation, because it studies the different stakeholders and different stakeholders' needs, and then we better understand how they can live in the future one day when the work changes. And we pay special attention to the experience, which is not always the case in service design. So because we take this service experience design method, we see the see the tools that we provide for the pilots as services for them. Although technology testing has been like the priority at this point, which is very natural. When some new technology comes in, you just need to make it work first, and then you start to adjust it to the needs of people. Well, this is not so simple. Of course, the needs should also drive the functionality of the technology. But anyway, even to get the remote control room equipment work, that's quite a task already. But one day, the new tools should serve the employee to excel at work and optimize the workflow, make it efficient, and so that the people can do their work in the best possible way. Then the second one here is that service design not only focuses on the actual activity, but what happens before the service is in use. What kind of preparations are needed? For example, before the piloting can start, what needs to happen? And also after the piloting, what will happen after that? And we want to support, we want to have tools that support meaningful work. Because the work transformation from vessel to office often might mean that people don't enjoy anymore their work, because there's so dramatic change. No wind in your hair when you are going to the ship, or something like that. Office work is office work, very different. This makes tricks for me. So we did this survey on meaning of work, but of course any statistics based on 3 pilot opinions shouldn't be reported anywhere, and we won't be able to publish this work in any scientific venue, but that's why I show it here. So it was, well, the questions are, or the statements are in Finnish, but I hope most of you understand. So luckily in this work, where is the pointer?
Middle.
Middle, okay. So the meaningfulness of work is very high here, and it's getting higher. So the blue line is when the remote pilots tested the system in simulator, and the orange one is after the demonstration, the real life, almost real life experiment. And of course, it's even more meaningful to be in real life than the simulation.
The important, interesting thing would have been seeing comparing their normal work, like
Exactly.
2020.
Yes.
Because now it can be like they have used for seafaring, and then when they get out to the vessel, they're happy again.
That's true. But I think these pilots who are now doing the remote piloting, I think they really find it very meaningful because they are doing something new. They are first in the world doing something. So that's why there was something about that they are proud of their work now, and they think that they are doing a really meaningful job. And I'm not sure if the traditional work was as high meaningfulness, but of course this is a special situation now when they are the pioneers. And then also this one is something that the social network, maybe it was not so important in their early traditional piloting work either. So maybe we will run some additional studies on that. How does it compare to the traditional one? How are we doing with the time? Do I have 10 minutes or 15-minute presentation?
Like 7 minutes left.
Okay, yes. So some positive aspects that we found from our studies, of course, or maybe not of course, but saving time and not having the maybe meaningless part of the work, sitting in the boat that takes you to the ship before you jump on the ship that you will pilot. So that's kind of the meaningless part that will be removed, and they were very happy about that part, that they don't have to be in that ship, on that boat anymore. And then safety improvement, of course, is something they are happy about, especially when you climb to the ship. That's a very dangerous part of the work. And fitness is required in this kind of job as well. But in the office, you can work even if your leg would be broken. And then, as I said, pioneer work can be very exciting. You learn a lot of new skills, and you develop, you grow in your skills, which is often very motivating at work. Of course, not everybody might think the same, but these three pilots were commenting on that. And then negative parts of this work change is that social contacts have been quite important earlier, and they said that there's less social contacts there. And then safety of vessels. The pilot feels that they are safer, but they are worried about how safe are the ships out there. And then new tools and new challenges come when you get new tools, they are challenged at first, because in this early phase it was obvious that the current tools are not very good yet. There was increased cognitive load, and they were quite tired after the demonstrations. Yes, So, and then the last thing I have to say before Johanna is that they actually would like to, even if they have remote office, they would like to work like they work nowadays, like a full week of work and full week of time. And if there's a remote control center, the location can be basically anywhere, because if that working hour system works, then you can just commute once anywhere where the remote control center is and sleep there. Yes. Now, Johanna.
Yes. Hello, Johanna Salokkainen from Norwegian University of Applied Sciences. So I made a presentation already, and this is part of it. But this was more related to your work than Arne's presentation. So I decided that I will present it here. So basically, here is a question about shift sense. And some of you saw already this, but just shortly, that currently the trend really is that the pilots are physically navigating the vessel, and they have a lot of vessels during the years that consider they can be, I don't know how many vessels for one person, can be, I guess, 100 piloting, or maybe more piloting trips. So considering that they take the vessel that comes in, they take the crew that comes in, they navigate in various environments, different weather conditions, and especially that particular fairway. So due to this, that they have actually gained a huge and wide experience base of different type of vessels, their behavior, navigation and maneuvering in various conditions. And this was actually observed that when we were doing the simulator exercises and testing these operational procedures, and also in the Nemo case, that this actually, their experience base supports also their decision making when they are not on board. And therefore the question is that considerations for the future, that if they start to be more and more remote pilots, how do we maintain this experience base at the same level that it is now? I don't have the answer now, but for the future considerations. And then two other key points related to this subject was that the work, this is actually what the pilots said themselves, that they found out that it's more tiring to do the same work, the piloting from a remote control station where they monitor and operate this piloting process than would be on board. So actually they feel that it might be that this is a novel field, it might be that it's new, it might be that the technology is not really there yet, but this is one of the findings that we had during our research. And this needs to be considered then with the technological development and smart presentation of information. But this is something that to consider in the future development of these workstations, work schedules of course, and breaks, and general coordination of work, and ergonomics, this basic. And the other observation was that, and they said it also themselves, that they noticed that they are much more careful when they are sitting in a remote operation center than it would be when they are on board. And they kept, for example, bigger distance to other vessels when meeting other traffic, or they could, for example, choose more safer ways to navigate the vessel that would be when they are. And it might be that they didn't quite trust the technology. So basically, when this technology evolves, it creates also trust, and they start to trust the system. And experience, naturally, experience and learning of the new work So it might be that being too careful, maybe they are not so efficient then. So maybe this efficiency and safety balance becomes, or maybe it's just a good thing. Maybe it's good that they are more careful. So thank you. This was from my part. My couple slides.
Do we have time for?
Thank you, Christian. Thank you, Joanna. Nice to have you as well.
Thank you.
Any questions from the audience?
You said that they are doing the same work, either on board or remotely, but I can see that the totally different type of work, although it's piloting, but I can understand that the setting where you are working is totally different, the tools you are using are totally different. So is it the same work?
Yeah, I don't remember me saying that. So because I talk about work transformation.
Yes.
So it's a huge transformation of work, and it will change a lot. But the basic purpose is the same. Yeah. Thanks for bringing that up. Then.
Yes, thank you for the presentation. I got stuck with this notion, or that you said that they want to maintain the same rhythm 7 days. I mean, everything is different somehow, and they want to keep the rhythm for why?
Maybe it's not work related.
They have organized their lives to be away for certain times, away from their family, and they have both homes distant from the fairway. They wouldn't come from 8 to 6 working time. Kind of, they wouldn't drive hundreds of kilometers to the office.
Yeah. So we should have asked their families as well. What is their preference?
Okay, thank you. And as I mentioned, the last presentation was pre-recorded.
Hello everyone, my name is Mikko Virtaneva. I'm from Workspace, and Workspace has been a subcontractor for Haltian during this project. Now I will present our concept. All right. The topic is human factor and socio-technical system in a remote pilotage. Today we will go through and define human factors and the system in this concept, how human factor and socio-technical system can be developed in a remote pilotage, what should be tracked and monitored to support the performance and development of remote pilotage, and finally I will present the space design when developing the emerging new service. First, let's look at the human factors. Here we have FinPilot's values from their website. These are safety, quoting, "With our competence, we will provide safety to people, maritime, and environment." Trust, we will trust each other and our partners can trust us. Learning together, quoting, "We will share information, benefit from our expertise, and create the best ways of working together." So these were the starting points for the human factor development. Then we created 3 perspectives to look at these values, and these perspectives were well-being, learning and developing, talent, attraction, and retention. These perspectives were chosen because they are critical for development of remote pilotage and performance. They support everyday performance and strategic development of remote pilotage, and they are based on FinPilot's values and support human factors found in maritime research. How to then use system analysis to understand the human factors and performance? In system analysis, we want to define the desired level of analysis and the level we want to affect and alter. Maritime traffic has a massive impact on Finnish industry, so trying to define its impacts on a very large system would be beneficial. The analysis of large-scale systems, here A, societal system, and B, piloting system, are very big and meaningful, but the assessment is more unreliable because of the very ambiguous nature. Then the smaller scale system, C, socio-technical system, and D, employee system, are smaller but more verifiable. The smaller systems are also subsystems to the larger ones. Now we will focus on the level C, socio-technical system. Here we have a more simplistic way of looking service profit chain system. We can argue that a good customer experience comes from internal service quality, which then provides the means for successful remote pilotage. According to Hesketh and others, the factors on the left in this system are internal quality factors that can be influenced. These include workplace design, job design, employee selection, employee development, rewards and recognition, tools for serving customers, and remote pilotage technology. Improving these will improve the performance and competence of the personnel. Then we dive into a more complex visualization of the socio-technical system. Here we have the largest scale, where we have our objectives and perspectives for human factor development, the well-being, learning together, talent attraction and retention. And here we have the resulting system we want to change by affecting the other parts. Then here we have relevant social factors and other factors within the larger ones to improve the analysis. Then we have the correlations and causalities placed in the same system. The green ones being positive correlation and the red ones meaning negative correlations. This graph then supports the understanding of the system, the rationalization of the system. And from here, we can start to monitor and track the system. To assess and analyze, we then introduced the impact outcome output input method. The most basic levels are the input, for example, the resources, and output, which is the lowest level of measurable work, for example, survey results. From there, we can track the outcome, which would be, for example, change in practicalities, culture, or attitude. And the most valuable level is the impact level, which would be the change in, for example, industry, maritime safety, costs, or employment. This is, however, usually very difficult since the assessment is very hard. But this is why visualization and rationalization of the system helps us to understand and find the valid indicators of change. From here, we can then create indicators to drive and monitor the desired change. The key performance indicators. Here we have the general well-being KPIs we created for this concept. On the left side, we have social factors, for example, workload. Then we have the measurement, some of these being more precise than others. On the workload, we have, for example, utilization rate, meaning the ratio between piloting and recovery. Then we have defined whether the KPI is critical in the early development stages of the remote pilotage station, or whether it should be used in more strategic long-term development tool. For example, the utilization rate is in the critical category, meaning it should be monitored from the beginning. Then each KPI was labeled either driving, monitoring, or outcome KPI. In here, we have used Osiris and others definition where driving KPI is applied to change, maintain, and reinforce different elements of the system. The monitoring KPIs provide information regarding the system activities and the internal dynamics. Outcome KPIs reflect a temporary end result of the activity. Here we have an example of a technostress survey. This one is adapted from Raghu, Nathan, and others' survey model. It could be used to complement the existing annual surveys. This survey studies how the new technology and its role in the work affect the well-being of the remote pilots. Now we can proceed to the design part of the presentation. How to support the remote pilotage functions and human factors with space design. Because of the very ambiguous and uncertain development of the remote pilotage, we regarded that it would be best to provide different options or scenarios regarding remote pilotage while it matures. For example, here we have 3 options where the difference include amount of personnel, the infrastructure around the station, landscape around the station, the fairway characteristics, the amount of different spaces in the station, and the possibilities to collaborate and share premises with other stakeholders. For example, in the option C, having also work spaces for VTS in the same space. In this picture, on the horizontal axis, we have the more distributed on the left, for example, meaning each fairway station has its own remote pilotage capability. And then we have the more centralized remote pilotage, where we have multiple different maritime organizations in the same working spaces. On the vertical axis, we have the more specialized competence on the bottom, meaning that each fairway station only serves the certain fairway. On the upper part, we have a more broader range of different competencies, meaning that there is different kind of knowledge, know-how from different organizations, and they could benefit from each other. From here, we made the grid for space requirements according to functions in the remote pilotage stations. On the top, we have the human factor objectives: well-being, learning and developing, attractiveness, and retention. On the vertical, we have the functions at the piloting station. The relevant to piloting event is piloting event and preparation and closing, and relevant to activities between pilotage events are the training and learning and training, resting and recovery, and recreation. Then on the grid, we have solid color circles, which means these are the most important aspect to focus on from the space requirement side. The empty circles mean that these are the second most important aspects to focus on. And then on the left, we have the requirements. This table shows, and which we have then written down there. Then we will go through a few examples from the space types and functions. Here we have a piloting event space. Some important aspects, not all, but some that came up in the discussions were good ergonomics, meaning the furniture, but also the possibility to move around the room, since there is no same possibilities to move around as in traditional pilotage. Also, because pilots saw that remote pilotage is cognitively much more demanding, so the space should be a very easy to navigate, and there should be a good sense of ownership of the space and cognitive ergonomics. There should also be coffee station and toilets very near. This was deemed very important. And well, obviously the space should be technically well equipped and with reliable connections. The preparation and closing events of the piloting. Here we have, for example, open and closed spaces. The closed spaces more for preparation, where you have only the necessary information in the space, and you can really have high concentration before you go to the actual piloting station. And then you can have the more open spaces, which is more for routine work after the event, for example, reporting, but also sharing information with other people at the station. But you can also have recovery and relaxing spaces near the actual remote pilotage workstation. Here, it was also seemed very important that they have good ergonomics and ambient conditions, such as good air quality. Then function between the piloting events, resting and recovery. This was one of the most important aspects that we found out during the interviews. There shouldn't be need to move between rooms during the pilotage week, and this is also related to the bigger phenomenon of maximizing possibilities to recover between pilotage events. Also, this space should have no passage or trespassing by other people than pilots, so it's pilot's own space. This is especially the case if there are other organizations present. The space should be inviting, cozy, logical, and clean. Another way to view the space and the functions in the space is zoning the station. Here we have a single fairway station. We have the learning and training, preparation and closing on the left, and the recreation and resting and recovery on the right. And we have the piloting in between. This is a larger maritime piloting station where again we have the piloting, high focus, preparation and closing on the left. And then we have the resting, recovery, recreation on the right, and the socializing, learning, training in the middle. To summarize this presentation, the human factor development should support the existing values in the organization. It should support the performance of the personnel. The system analysis supports impact analysis. This should be done on both small and large scale. KPIs provide means to drive and monitor change and outcomes. A design of work and space should support the functions that are vital to pilotage, both while piloting and between piloting events. If you have any questions regarding the concept or our work, please do not hesitate to contact me. Thank you for listening.
No questions from me.
Yes, thank you, Mikko. Oh,
He's returning.
no. Okay, on behalf of myself and DIMECC, I'd like to thank every one of you for participating this session and the whole seminar. Hope you had fun, learned something new. The official part is now over, so get over there and have some drinks on us. Thank you.
Thank you.